This clip is about the application of logistic and ordinal regressions in research, especially using the VSP statistical package. Now we need to know exactly what logistic and ordinal regressions represent in research. When the outcome of your data falls into a type that gives you only one of two options, then it is time to consider Logit regression, which is a binary-based analysis. But when your analytical outcome expectation is the type that is based on ordered categories, then ordinal logistic regression is the most appropriate. Beside both of the two analyses are referred to as logistic regression because they both deviated slightly from the normal cause and effect numerical regression analysis using binaries and categories instead of real numbers. So with Logit regression, the dependent variable must be of binary type, that is using 1 or 0, while the predictors can be continuous, nominal, or scaled categorical variables. But with ordinal regression, the dependent variable must be of ordered categorical value, such as excellent, good, bad, normal, abnormal, expired, unexpired, agree, disagree, neutral, and so on and so forth. That means that the outcome variable of ordinal regression does not use numbers, and where numbers are used, the numbers are there just as options of choice and not for mathematical manipulation. As with Logit regression, the predictors of independent variables, the predictors or independent variables can be continuous or scaled categories or nominal values. Researchers can employ the use of any of the two logistic regressions when it becomes difficult to collect complete secondary or continuous data, or when it is more convenient to use questionnaire-based primary data rather than secondary data. Now, Logit and ordinal regressions compared. Logistic and ordinal regressions are commonly used in research data analysis for different reasons. Logistic regression. Logistic regression is used when the dependent variable is binary, just like I've said earlier, that it has only two possible outcomes. Either it is there or not there. It helps in understanding the relationship between independent variables and the probability of a specific event occurring. Researchers often use logistic regressions in studies where the outcome of interest is a yes, no, or pass, fail, or present or absence type of variable. It is widely used in fields such as healthcare for predicting the likelihood of a disease, And then marketing for predicting customer behavior, and so on and so forth. Then we'll now look at the ordinal regression. Ordinal regression, on the other hand, is when the dependent variable is ordered or categorical with more than two levels, but the levels have a clear intrinsic order. It is used when the outcome variable has a natural ordering, but the intervals between categories are not necessarily equal. Researchers use ordinal regression when dealing with variables like satisfaction levels, like low, medium, high, or education levels, elementary, high school, college, and so on and so forth. We shall use two cases to demonstrate the use of the two. Case 1, we are going to use the case of telecom service customers to demonstrate the use and understanding of the Logit, that is the logistic regression itself, the one that uses binary. Now let's go. Case 1, telecom service customers. A telecom company wants to know the factors that influences customers to stay long in their service. They collected data relating to 60 of their customers, which include age, gender, education, wireless service, data service, call service, credit facility, and the length of stay with the company. Now, when we talk of wireless service, that is the customer subscribe to wireless service or did not subscribe. Then data service, whether the customer also subscribe to data service or did not subscribe. And then the call service, whether the customer makes call or does not make call. And then credit facility, whether the customer is a credit customer, that those who are billed after a time rather than those who are billed per postpaid. Now let us see how this goes. Age was collected as a continuous value. That's education as a scaled categorical value. Gender as binary, that is 1 for male and 0 for female. Then wireless data, call and credit facility were also collected as binary values, with 1 indicating subscription and use of the service, and 0 indicating non-subscription to the service. The dependent variable, that's long stay, is also measured in binary in agreement with the rules of logistic regression, with 1 indicating long stay and maybe, long stay maybe more than 5 years, and 0 indicating short stay, maybe less than 5 years. Now the snapshot of the first 15 records of the data set is presented here. Now let us look at it. You can see it. Now we are using the Excel data sheet, and this is how it appears on the data sheet. The columns A, B, C, D to I are the one that is holding the data. Now the first column, which is column A, is customer ID. The second column is the age. The third column is the education. Fourth column, gender. Fifth column, wireless. Sixth column is calls. Then seventh column is data, and then eighth column is credit facility. That represents at credit, and then the last column, which is I, is the dependent variable, which is the long stay. Now you can see from what you are seeing here that customer ID is not part of what we are going to analyze, but just a way of using to identify the customer. But then age is a continuous variable. You can see it. So it varies according to the age of the driver, 23, 31, 25, 19, 42, 50, and so on and so forth. Then the education also varies according to the education level. Now that is a kind of a categorical one. You have here you have one maybe for primary, 2 for secondary or high school, then 3 for college, and then 4 for higher college or higher education. Now, the third one, the third of the predictor variable is gender. So you can see here, 1 represents male, 0 represents female, and then so now so just only 2 values. That is the binary you are talking about. And then the fifth one or the fourth one is wireless. Whether the person subscribes to the customer subscribes to wireless service or not. If he subscribes, that is 1. If he not subscribed, that is 0. Then calls. Whether the customer is a call customer, whether it makes call, that is subscribed to call service, that is shown by 1, and then not subscribed is shown by 0. And then for data, those who subscribe for data is shown by 1. Those who subscribe, who did not subscribe, is shown by 0. And then for the credit facility, those who enjoy credit facility identified by 1, those who don't enjoy the credit facility identified by 0. And then of course you see the long stay, which is the dependent variable, as they are marshaled out in 1, 1, 1, 1 and 0. 0 indicating short stay, while 1 indicating long stay. So that is about that. Now we have just seen this. We are going to enter this into the VSP by the time we deal with the second case. But now let us look at the second case very well. The second case is a vehicle condition. The researcher is interested in understanding the factors that contribute to the conditions of a vehicle. A vehicle condition can be categorized into 4, namely excellent, good, usable, and then bad. The researcher postulated that the driver's age, the number of accidents the vehicle has had, the frequency of maintenance are represented by MTCE, the frequency of usage, the size of the vehicle's engines, that's in cubic centiliters or cubic capacity. Then the condition of the road being plied by the vehicle. You know, road condition can also affect vehicle badly. That's what is labeled as road con. And then the driver's experience is the last one, which is given as driver. Now this is where the data is brought out. You can see it's also in Excel, even though the ABCD column name did not appear here now, but it's in Excel also. Age is here, just like age is in the other one. And then accident is here. That is as one of the predictors. Accident here means that, you know, if there's 1, which means the person has had 1 accident. 2 means 2 accidents. 3 means 3 accidents. And 0 means it has no accident at all. Then maintenance, frequency of maintenance. This is what we're talking about, say 5 maybe in a quarter, 5 times in a quarter, or 4 times in a quarter, or 10 times in a quarter, depending, or 6 times. You can see this is kind of a continuous variable. The same thing with usage. Usage is also a continuous one. And then the usage is how often is it used, maybe in a day or in a week. And then the engine size is the one that we're talking about, the one that will measure in cubic capacity or cubic centiliter. And then the road condition here is 1 for a fairly good road, 2 for a good road, not as good as number 1, and then 3. The only 3 categories here is a bad road, a road that is already begging for reconstruction or attention. Then the driver, this one is the experience of the driver. 1 means experience or driver, inexperienced driver. Then 3 is a highly experienced driver, and 2 is a fairly experienced driver. So that's how it is. And now you can see the condition here is the outcome. Now, for number 1, which is the record number 1, that's observation number 1, the vehicle is still in usable form. For 2 is still in usable form. For 3 is in excellent form. Then for 4 is in good form. 5 in good form. 6 in good form. For 7 is in a bad shape. So it's in a bad shape. So that's how it is. And then now the data for the predictors were collected as continuous, as we have explained and as we have seen. Then continuous and ordered or scale ordered categorical numeric values, while the outcome variable, that is the condition, was collected as ordinal categorical, that is non-numerical variable, as we have just seen from there. So now, well, let us call up the VSP and see how we are going to deal with these 2 cases now. Yeah, that's the VSP. Call it up, and then we can okay, so now we have more room. Yeah, so now we have more room to manipulate. We have cleared the screen. So now we now go on to the site data analysis. We click it open. Then we now go to the logistic regression, and we go to Logit regression, which is the first one. We wait for the form to come up so that we can fill it up. Yeah, well, it takes a little time for it to initialize and then come up. So that's that, but you don't need to worry. It will soon be done. Yeah, so eventually it is here. So now let's fill it up. Okay, the outcome variable for the logic data here, like we said before, the outcome variable is a long stay. Remember, that's what we had, the long stay. That's the outcome variable. Now, the predictors we have are age, education, which is edu here, and then gender, can see, like before, I'm just separating this predictor with only comma, no space. Gender, then wireless. Always ensure that the spelling matches the one that you have in the data set file. And if they are in small letters, use small letters. If they are in capital letters, use capital letters. Then wireless, after wireless, we have calls. After calls, we have data. After data, what do we have again? Credit. Yeah, credit. For credits and facility. So, and that is the end of it. So we now go on to this one. That is the data set file name. The data set file name here is called Telecom 1. That's what we use in saving Telecom 1. Telecom 1, that is it. So, and then we now process. Yeah, I think it has finished. Yeah, so now, first it is showing us the plots bar chart first. Yeah, and this is line graph. This is the density plot. The density plot. Yeah, this is the bar chart, but this one is horizontal bar chart of what we have. You can see that you see data, you see credit, you see data, you see calls, you see wireless, you see gender, you see education, and then you see age. You see the way they are. Now, what I want to tell you now is that this, what you are seeing here, are not the actual data that you see in your data set, but these are the coefficients. It is the coefficient that the system, graphed so that you see the coefficients. While some are positive, some are negative. I think almost all of them are negative, and one, which is the age, is almost just 0, just very little. Then the one that is positive, I think, is gender. That's the one that is positive. Now let us now take off this graph, and then we now look at, since the graph has finished showing. Now let us now look at the data, or the result of the analysis. First, as before, it will start with the data set used. You can see it right from what was on that particular data set in Excel, the way it is, all of them, and then to the last one, which is just 60, and then we just have the VSP logo, and then it now gives us some pre-estimation tests, variance inflation factors, which is this. I'm not going to talk on the interpretation of this, as I leave the viewer to go and study it and see what it is all about. Then it is now saying optimization terminated successfully. Yeah, it is reporting that optimization terminated successfully. Current function value 0.576014. Iterations, that's 6 iterations. Now, this is the Logit regression result. Now, the dependent variable is long stay, and then the model used is Logit, and then the method is MLE, and covariance type is non-robust, and converge is said true. Yeah, so, and then we now come to the other side of it. The other side is talking of Number of observations, that's 60. Degree of freedom of residuals is 52. Degree of freedom of model is 7. So now the pseudo R squared is 0.1441, and then log likelihood minus 34.561, and LL log likelihood null minus 40.381, where LLR p-value is 0.1130, which is not as significant as it's supposed to be. Now let us now look at others. Let us look at others. Now this is the second one, and these are the coefficients. Actually, these are the things that was plotted on the graph for you to see the coefficients, because those are the ones that really matter. Shows the type of relationship that that long stay has with each of those factors. And now, for instance, age has nothing to do with long stay. That is exactly why it is showing 0.0. And then education has minus 0.41. That is negative relationship with that. The only one that has positive relationship is the gender. That positive relationship, that the way, how long they stay, that is that one. And when you look at the p-value, you can see that it's only the gender that is actually significant. All others are not significant. You see the confidence interval, the lower confidence interval, and then the upper confidence interval. Now, coming down, you have the log likelihood ratio test, LRT, is 0.1130, and so on and so forth. So now, then the predictors. Now you have predictor one. Predictor one is age. Predictor two, education. Predictor 3, gender. Predictor 4, wireless. Predictor 5, calls. Predictor 6, data. Predictor 7, credit. Now, you see, each of the predictors have their word tests chi-square, and this is exactly what they are showing. The word test chi-square statistics is for the first one, which is age, is 0.10, and then so on and so forth. So now, and then for gender, the same thing. See, the same p-value that was returned by the coefficient is also what is returned in the word test. And then the degree of freedom here is of denominators 1. Yeah, so this is a very robust estimation using the Logit. And at the end of the whole thing, it's now showing us that our logistic test results have been saved to C value stats Logit results.txt, while all these things that you are seeing, that's all the graphical plots are also saved as C value stats Logit PNG. So that's that. Now we now go on now to do the second one, which is the ordinal regression. We have done the Logit now, and let us do the ordinal regression. We still go back to that logistic, and then we'll now choose ordinal. Yeah, so we wait as before for it to come up. Wait for it to come up. We are talking about the form, the data definition form. Well, And it takes just some few seconds to come, but it will come. You just have to initialize very well so that it can, yeah, good. It's out now. If it doesn't initialize very well, it means that it may not capture exactly what we want it to capture. So the outcome variable this time around, remember we said the outcome variable now is condition based on what we saw on that dataset file. That is condition. Now let's code condition. And then after condition, go to the other one, and then the condition. After the condition, which is the other one, then we now enter all the other predictor variables. Age is there, just like it is in the logistic one. Now, after age, you have accident. It's not really accident. It is not really compulsory that you must arrange them the way they appear. You can vary them. For instance, instead of putting maintenance, now I can just put engine size now. I can put engine size, and then we can now put usage. Now I put maintenance. After maintenance, you can put road condition, or you can put driver first before road condition. Yeah, so the next one is road con. Yeah, if everything goes well, that is, everything is entered the way they're supposed to be, there will be no problem. Just make sure that there is no space. Then you didn't capitalize where you are not supposed to capitalize. And the next is a go-go, a win-win. Now, the name of the dataset file is vehicle. That's what we use to save vehicle.xlsx, but we don't need to put that xlsx. So we don't need to put that. So the system already know that we are talking about Excel file. So we click process and see, okay, good. It has finished processing. Yeah, this one does not produce graphs for now because of as a matter of fact, it gives more information, more comparative information than the Logit. Now let's see what it's all about. Yeah, let's see, starting from yeah, this is where it starts. Then here it goes to the descriptive statistics. By the way, it also shows the other, like the other one, it also shows the data sets used. But this time around, because the data set is so vast, you can see 840. That's what's or rather 841. That's what the data set, I mean, the observation is in the data set. It's so large. So it's only showing us the first 5 and the last 5. So with this, you can proceed. Now, this is the descriptive statistics. You can see that the count, which is the number of observations, is 841. The mean is this for age, for accident, for engine size, for usage, for maintenance, for driver, for road condition. Those are that. And then you have the standard deviations following the mean. You have the minimum. You have 25%, you have 50%, you have 75%. Then you have the maximum, which is here. That's the maximum value for each of them is there. You can see none of them use just 1 and 0, but all of them use the other use continuous, as with age or with usage, engine size also, and then maintenance. So while the other one use categorical, but it's numbered, that's scaled categorical. Now, this is the variance inflation factor, showing that usage, in this case, usage with 20.4 is highly correlated. Yeah, so that's it means that they so much resembled each other, just like that. That's what it means. And then you have the correlation matrix here. If you look at that usage, you can see that it is correlated highly with maintenance and with road condition. So, and that's it. So now, warning. The maximum number of iterations has been exceeded here. Current function value is 0.583620. Then iterations is 35 iterations. Now, the start model, this convergence warning, maximum likelihood optimization failed to converge. Check MLE, okay, but that warning is not fatal to our analysis. It's not fatal. So yeah, we can now see the Logit, Logit. Now this one, the former one use Logit, but this one use Logit. I use MLE as the method. So the model is Logit, just almost like the other one. Then this, the dependent variable is condition. Now, number of observations is 841. Then the degree of freedom of residual is 817. Then degree of freedom of model is 21. Then pseudo R squared is 0.5682, which is fair enough. And then plus others. Now we go on to the coefficient. Now the coefficient is organized according to the conditions that were given. We have 4 conditions, but it's only going to do the only 3 of them. Now the first condition was excellent. That when a vehicle is excellent, what are the factors that may affect it? Now, what we are seeing here is that maintenance affects the excellent condition positively. Engine size also affects it positively. Road condition affects it positively. But usage affects it negatively. Driver's experience also affects it negatively. And then accident affects it most negatively. Age also affects it most negatively. Now, when you look at it, let's see from the Z score, because using Z score now instead of using Z value now instead of the T statistics, uses Z statistics. Now look at it. When you look at it, you see that those that are significant here is one, the maintenance with 0.000, two, the engine size with 0.0004, and then after engine size you have the road condition which is 0.003. All others are not significant. So that is for that. Now it has left the good condition. You're now going to, it has left the excellent condition. You're now going to good condition, because it's analyzing them according to those variables that are in the dependent variable. The variables there are excellent, good, usable, and bad. So now this is now comparing good. So the one maintenance is also positive to good. The engine size is positive. Road condition is positive. Driver also is positive. But age, accident, and usage are negative. Now let us now see the ones that are significant there. The significant ones here, are 3, and those three are accident is significant, usage is significant, and engine size is also significant according to the p-value here, and that is it. So now let's still move up. Now we have the third condition, which is a usable condition. In usable condition, maintenance is positive, engine size is positive, and then driver is also positive. And then when we now come to the one that is significant, only 2, and that 2 is accident is significant here, and that's negatively significant anyway, and maintenance is positively significant. So it means that accident also affects the condition of a vehicle. Accident affects it, so that's what it's trying to show us. Now let us now go to another one. So it did not mention anything about bad, but it compares what it has done here with others. Now look at, it's now showing the ordinal Logit post hoc analysis. Post hoc is very important here because that is the diagnostic aspect of it, trying to show more information than what the coefficient and the p-values are showing. Yeah, so, and this is good. Now after the post hoc, is now comparing the condition, each of the condition with the other ones. Is comparing, the first comparison here is excellent compared to the constants, and then this is the value that you have. Confidence interval at lower confidence is 0, 0, 0, and then upper confidence interval is infinity, and then excellent compared to age 0.91, and then the other 1 point something, and then excellent compared to accident is also like that of constant, So it means that, excellent and excellent does not go together. And then excellent and maintenance, yeah, very, very positive. You can see the large amount of it for the confidence interval, the lower confidence interval has 25.05, and then for upper confidence interval it has 73.8, and they are all positive. Now it also compares with usage and all of that, which are also positive. Now you leave the excellent condition to good. Good also compares to all the other one except the one that has compared with it before, which is excellent. Now when you leave good, it will go to usable. Usable compares with all others also except the one that compares with it before. So, and that's what we have here now. So it's a very robust one and full of lessons. That is the ordinal logistic regression, and it is even better when you use the VSP to do the analysis. So it'll be better for it. Yeah, thanks for watching.